Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about noise introduction and what is noise and what is the importance of the noise. So first of all, what is the difference between noise and signal? Signal carries some wanted information and noise is also a signal. It carries some unwanted information. In the context of signals, noise may be defined as an undesired or unwanted electrical signal which accompanies the desired signal. Signals in the transmission always pick up some undesired signals. Noise in an unintentional fluctuations that tends to disrupt transmission and reproduction of transmitted signal. So there are the various sources of random noises are the various source of random noise are classified as there are two types. So that are external noise and internal noise. And what is external noise and what is internal noise? So external noise is the type of the noise generated by outside the linear systems which are predictable in nature and out of human control. And what is internal noise? So internal noise is created by the active and passive components present in the circuit itself. So that is the types of the noise source, that is external noise source and internal noise source. And some examples of the noise are power supply fluctuations produce hum noise. And second one is in radio receivers, noise may produce a hiss in the cloud speaker output. And third example is in TV receivers, noise appear as snow on confit. That confit means colored snow. That is white or color spots on the screen along with the picture. One more example, radiation pickup generated by electrical devices or electronic devices. So these are some examples of the noise. And what is the noise effect? The noise may produce unwanted pulses or may cancel desired pulses in pulse communication system. And noise may cause serious mathematical errors in computation. Noise can limit the range of systems for a given transmitted power. It affects the sensitivity of the receivers and may reduce the bandwidth of the system. So these are the some effects of noise. Next, we are going to discuss about thermal noise. So thermal noise is also called as a resistor noise. And what is thermal noise? The thermal noise or Johnson noise in any conducting material, electrons move randomly. The noise produced is called a thermal noise. So this thermal noise is also called Johnson noise. Each free electron inside a conducting medium is a motion due to temperature. When the temperature increases, random motion of electrons increases and hence noise increases. The analysis of thermal noise is based on the kinetic energy, which shows that the particle temperature of a particle is a way of expressing its kinetic energy. So the noise power generated in a region is proportional to its absolute temperature and the bandwidth over which noise is missed. So that is P suffix n is directly proportional to TB. So the expression of maximum noise power output of a region is given by P suffix n directly proportional to T into B. So that is equal Pn is equal Pn is equal K into Tb, where K is the proportionality constant. The proportionality constant K is a Boltzmann constant. That Boltzmann constant is given by K is equal 1.38 into 10 to the power of minus 3 joule per degree Kelvin, and capital T is the temperature in Boltzmann constants, temperature in Kelvin, and capital B is the bandwidth in hertz, and and the noise power is okay. So P suffix n is the noise power. So removing the proportionality, we get Pn is equal to KTB, where small k is the Boltzmann constant. That Boltzmann constant K is the that K value is 1.38 into 10 to the power minus 23 joule per Kelvin, and capital T is the temperature in Kelvin, B is the bandwidth in Hertz. So this is the thermal noise definition and mathematical expression.